asteroid that killed the dinosaurs boiled the Earth's atmosphere. This is a revelation. It's an article on The Conversation by Claire Belcher, University of Exeter, and Rory Haddon, the University of Edinburgh safety engineer. The asteroid that wiped out the dinosaurs set off an intense heat wave that briefly boiled the Earth's atmosphere, but it did not burn off all the plants. Humanity has not been unlucky enough to observe at first hand the effects of the large impact, so to investigate whether a massive asteroid would spark off a global wildfire, we had to turn to the laboratory. We had modeled for the first time the heat generated by the impact and what it meant for the planet's plants. Our research is published in the Journal of Geological Society. This all happened 65 million years ago at the end of the Cretaceous period, when dinosaurs still roamed the Earth. Suddenly, between 60 and 80% of all living species became extinct. Until the 1980s, this catastrophic loss of life was a mystery, but then scientists found a clue: traces of the element iridium in rocks of this age. Iridium generally falls to Earth with extraterrestrial objects. This suggests a massive asteroid collided with the planet, and that this could be responsible for the mass extinction. 10 years later, the scientists found the 65-year-old, 180-kilometer wide Chicxulub crater on the Yucatan Peninsula in Mexico, which finally provided the smoking gun that could explain the apparent chaos at the end of the Cretaceous era. A crater that wide suggests that an asteroid or comet approximately 10 kilometers wide hit the Earth at that spot. The impact would have released a huge amount of energy, equivalent to more than 1 billion Hiroshima bombs. The asteroid itself was vaporized as it smashed into the Earth, and in doing so, vaporized and blasted out particles of the rock that it hit. A huge glowing ball of rock and vapor rushed up from the impact site at huge speeds, ejecting it away above the atmosphere up into space. As it hit the cold of space, it decelerated, cooled, and rained back through the atmosphere, resolidifying and forming tiny droplets of rock known as spherules. All these spherules fell upon through the atmosphere. They were subject to the same frictional drag which causes space shuttles to become superheated as they return to Earth. This in turn meant as the particles rained down through the atmosphere, they delivered a massive blast of heat to the ground. Scientists call this a thermal pulse. This heat pulse has widely been suggested to have ignited global wildfires and has been cited as a cause of the mass extinction. Recreating the impact, new computer modeling techniques have enabled us to generate better estimates of the heat pulse resulting from this impact. We found it was not evenly distributed across the surface of the Earth. Areas close to the impact site experienced a strong but very short-lived pulse, reaching a peak heat flux of around 50 kilowatts per square meter. That's 20 times higher than a human can tolerate for around 1.5 minutes. And further away, the maximum heat flux was lower, at a peak of 20 kilometers per square meter, but lasted much longer, up to 7.5 minutes. We teamed up Earth scientists with fire safety engineers to investigate whether this heat would lead to a massive global wildfire. The heat pulse from the asteroid impact was recreated using state-of-the-art apparatus usually used to test the flammability of furnishings and materials. This provided for the first time the ability to test whether the heat pulse from the impact could have set fires to the world's plants. Our research reveals that the short, sharp blast of heat felt closer to the impact could not have ignited live plants. However, the longer drawn-out pulse further away from the impact may have started fires in some locations, implying that localized fires may have occurred, but critically, global firestorms were unlikely. This turns our understanding of the heat pulse on its head as its effects would have been greater further away from the impact. Earth scientists will have to reassess their understandings of the fossil record of life. Until now, they have assumed the heat pulse was stronger closer to the crater, but now patterns of extinction and survival must be reinterpreted by considering a more severe heat pulse further away. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.